Okay, for this next video, we're covering section 3.2, which is climate, weather, and life. Our learning objectives, you'll see 5 listed. There's kind of 3 that we're really going to focus on. First, explain how weather and climate are different. Describe how Earth's climate and average temperature are determined. The next 2, we'll cover a little bit, but it's not a huge focus as far as ocean currents and regional climates. And then finally, we will start to introduce the processes involved in climate change. So first, differences between climate and weather. Let's see if I can get these words on. So weather is just the day-to-day conditions of Earth's atmosphere. So this is a temporary condition that can change very often. Whereas climate, you're looking at long-term patterns of both temperature and precipitation over many years. So things that will determine the climate, again, we said primarily precipitation and temperature, but you can also add in some wind, clouds, things like that. If you want some more information about factors that impact climate, please watch the video that's embedded in the PowerPoint notes. But if we're looking at the global climate system, primarily this is going to be controlled by 2 main things: the total amount of solar energy retained as heat through the greenhouse effect, and the unequal distribution of that heat between the equator and the poles. In other words, how does the latitude of a location impact the distribution of heat? So if we're looking at solar energy and the greenhouse effect, we have this analogy picture as to why we refer to this Earth condition as the greenhouse effect. And what's happening is the Earth is basically acting as a giant greenhouse, and particularly the atmosphere is acting as the glass that is retaining the heat. So the energy enters as light, and then much of it just gets trapped within the atmosphere, or in this case within the glass, and some of it might escape back out as it passes through those glass walls, or in the case of the Earth, passes through the atmosphere. So if we look at this as an actual situation, we see some solar energy is reflected, some is absorbed, and some is just re-radiated as heat. And so we can see there that yellow arrow is the energy that is reflected by the Earth's surface. The red arrows are showing heat absorbed and re-radiated by the greenhouse gases and retained in the Earth's system. And then we can see a little bit is lost to space and is actually escaping outwards from the atmosphere. Okay. And so what's controlling that? We have the greenhouse gases in the atmosphere that are causing heat to be re-radiated, particularly things like CO2, methane, and even water vapor acts as a greenhouse gas. Okay, our second factor we mentioned was latitude and solar energy. And with the location on the Earth will determine how direct the sunlight is on the Earth. So in the tropical regions, in this purple region, they're going to get the most direct sunlight at any one time of the year. As you go farther from the tropical regions and farther from the equator, the light's going to get less direct. And so the result of that is that we have 3 climate zones. The polar climate are the regions from the far northern and southern regions of the Earth. You can see them shown above the 66.5 degree north or below the 66.5 degrees south latitudes. And they're going to be the coldest regions. The tropical zones surrounding the equator in the purple region are going to be the warmest climate zones, and then the temperate zones between those two, which is a pretty wide area between the two, are going to be the more moderate or temperate climates. And we'll often see the biomes on Earth will match up to these general climate zones. So a quick discussion of ocean currents. Ocean currents and global winds are just caused by differential heating between things like the cold surface, the warm surface, and then other currents that are that are deeper within the water. And we see these various winds just from regions of warmer and colder air and how warm air rises, cold air sinks, etc. Sorry, my dog is barking in the background. Please ignore. For a second, let's look at this picture. This is from somewhere in California. And you can see some extreme changes across this region. And these are the highs for one particular day in August 2019. And you can see everything from a high of 71 degrees along the coast to highs of 119 degrees in this area around like Joshua Tree National Park and places like that. So what could cause these extreme differences in a relatively small area? And we say that these are regional climates. So what's going on? These are affected by things like latitude, by heat transport and moisture from winds and the ocean currents. Again, our coldest temperatures in that picture were closer to the ocean, but also geographic features like mountains, large bodies of water, ocean currents. If we look back at this picture, in fact, the Pacific Ocean has some very cold ocean currents that are going along this coast. So that's one reason it's keeping it pretty cold. There's also some mountainous regions along the coast as well. And on the other side of that, we see some much higher temperatures where maybe the moisture and things like that aren't getting across. And so instead it heats up very, very fast because moisture in the air has a insulating capacity, and it will absorb the heat instead of the air if there's moisture there. So you instead can see a lot more heating in areas where less moisture is reaching. So if we're talking about changes in climate and climate change and global climate change, this is looking at changes not just of temperature. That's why we don't say global warming anymore. We say climate change. But we're looking at changes in temperature, but also changes in clouds, winds, patterns and amounts of precipitation. And a big one that you've heard about in the news more recently is frequency and severity of extreme weather events. So are we seeing more hurricanes because of climate change? Are we seeing more fires because of droughts and things like that? So there are non-human causes of climate change. We will address some of the human causes later on in a later chapter where we talk about, in general, what are some ways humans are impacting the environment. But some of the non-human changes include things like solar output, Earth's tilt in orbit, meteorite impact. They think that's what caused all the dinosaurs to die off, was from climate change from giant meteorite. But even distribution of continents and oceans, mountain building, and the creation of new volcanoes can also have huge changes of Earth's climate. I think there was a year in the 1800s where they called it like the year of winter, and that was because the entire large portions of the globe were very, very cold, more so than normal, and it had to do with a volcanic eruption on the far side of the Earth that many people didn't even know was going on. Okay. And so we're going to end this section on climate here. And in the next section, we'll build on this to start introducing, in general, biomes and aquatic ecosystems.